It's been a minute since the Elantra's been in one of my videos because the shop has been full of two other projects, as you've seen. But finally I'm able to get around to completing the E85 fuel system conversion to see what that does. I got some new injectors that I want to put in here because my low impedance 850s just aren't big enough for ethanol consumption. But first, I know I have a boost leak because I can hear it and feel it. Got the tool all clamped up, and I'll issue a warning for all the headphone users and those with pets in the room. My fault apparently, isn't it always? Throttle body bolts backed off. Not a fun one on this car just to inspect gaskets, but whatever. If I'm going to install injectors on this car, all that has to come apart anyways. The ground bracket obstructs the fuel rail. I packed a lot of stuff in this area because what choice do I have with squeezing this engine into this chassis? But to get to any one thing, that creates a process, and I have to take everything apart in the right order. Now, I set lots of booby traps in here for myself. But anyway, once you've got the fasteners loose, I then have to remove the map sensor that I foolishly installed on the ground bracket thinking it was convenient. And only after I remove the ground bracket bolts can I remove the throttle body ground and support bracket. Just so I can remove that elbow. Taking the whole upper intake off gives me the most room to work, so one silicone coupler later, my upper intake reminds me that it also has a temperature sensor and a water methanol nozzle on it to have to disconnect. I have to touch so many other things just to get the elbow off or to access the fuel rail that are both right here on top of the engine, staring me in the face. It's just unique to this car. Looks to me like the boost juice is staining the aluminum casting in my intake. I don't really care, I'm just making this observation out loud for your sake. Some of you might care. The rail's held on by three 12mm bolts that also secure the throttle linkage brackets. You just have to be mindful of the spacers below the rail that the bolts go through. Try not to damage or lose those. That sounds easy enough, but each DSM style injector has a retaining clip on its connector that needs to be carefully picked free to avoid launching and losing it. It's only because I routed them over the fuel rail that I have to do this first. If you go under the fuel rail with your injector harness, then you could remove the rail, start pulling injectors out one at a time, leak a bunch of fuel, which I look forward to doing anyway, and more easily manipulate them to get each clip from any angle you want to access them from. I figure that since I already had to remove 13 things just to get to this point, what's 4 more? I went with fuel injector development 1200cc injectors, and these are plug-and-place DSM style injectors that fit my fuel rail, spacers, connectors, everything. They came with a spec sheet illustrating each injector flow rate based off of its own unique ID number, as well as the measured dead times at different voltages, so that I can fine-tune my fuel settings and keep everything within balance. They also came with a new set of injector seals, and there's nothing wrong with my old ones. I just tend to keep good, still squishy injector seals paired up with the injectors that I was using them with. So I'm going to change all these things out. This provides an opportunity to clean and inspect the injector seal bosses. These instructions say to lubricate both the upper and the lower injector seals with WD-40 or a motor oil equivalent. I'm not a believer in that the lower seals need that. I prefer those going in dry. You just have to be careful and watch out for sharp edges. I just like these dry because I know that I want the seal to grip, and there's boost on the other side of that hole. It's just me, I guess. I didn't follow the directions here. I'm a rebel. On the top side of the injector, that's a whole different story. Some fuel rails do like to cut seals when you insert them, and I don't have that kind, but aligning 4 of them into the holes at once is quite a handful. So my equivalent for this today is air tool oil. Air tools are loaded with O-rings, and this is totally safe on all of them. Fuel rail bolts all get hand tight. Maybe a little bit less stank than you'd put on a spark plug, but you'll be able to feel it. To finish this part off, I just reloaded the clips into each one of the injector connectors again, training each one into place with a pick, and then snapped each one down onto their new injectors. That wasn't so bad. I installed the 4 things. Now I just need to put the other 13 back on here, and we can start tuning. But first, I want to inspect those throttle body gaskets. Everything looks pretty good to me. They don't appear damaged, and so sort of to reactivate them, I'm just spraying both sides of the gasket with soapy water. This thermoseal material is somewhat porous on the surface, but it's fluid resistant. I'm just doing this sort of thing to fluff up the surface again before I squish it all back down. It's convenient that my boost leak problem was right in the middle of the exact same job that I needed to perform anyway. The ground bracket and the elbow are the first two of these 13 other things that I have to reconnect, and you can bet that I'll put a little extra stank on these this time around. Boost leak testing is a necessity every single time you upgrade injectors, because the next thing that you're going to have to do is retune your whole fuel system. Any boost leak your intake has will become a permanent part of your tune if you don't fix it first. So you want your intake in its most optimal, leak-free state before you even begin. That way, once your tune goes out of whack, you can most often correct it just by fixing that new boost leak that you didn't know about that showed up. If you do it the other way around, then all of your tuning efforts were pointless the second you fix the leak. And that also means that you were down on power and efficiency the entire time. So fix your boost leaks. That wraps up the injector install. Next up is to install a fuel injector clinic resistor pack delete plug that I bought from Import Image Racing. It was around $20 plus shipping, and it saved me the time and trouble of having to make it. I'll show it to you in a minute. The OEM resistor pack is needed for low impedance injectors. All it does is drop the voltage and current used to fire the injectors. High impedance injectors have that resistance built into each injector, so they don't need a resistor pack. This part of the job is so easy I actually had to go through additional efforts to be worth even demonstrating. The goal here is simply to remove the resistor pack and plug in a shunt into its connector. It raises the voltage from 5 volts to 12 volts, giving the high impedance injectors the signal they require. It's that simple. Here's the shunt. It just connects all 4 resistor power wires directly to battery voltage to bypass the resistors. Nobody but me's probably ever referred to this part as a shunt, but I assure you the vocabulary is correct. And if you spend the $20, this is all you have to do with it. I'm just putting the last parts of the intake back together and removing tools from the engine bay because it's time to start with the tuning portion of this thing. While you can usually start the car after making this kind of change, it's probably not going to like it until you rescale your fuel delivery so that the right amount of fuel is being delivered for whatever your airflow is doing. I'm using ECM Link, and the first of many places I'll visit is the Fuel tab to set global. ECM Link gives you a handy calculator on the Fuel tab that gives you baseline numbers that your injectors probably might like. So I'll start there. Click Calculate, Use, save that to the ECU, and let's go ahead and see if she wants to start. I didn't prime the rail or anything after the swap, so it's probably not going to fire right up, but we'll see. You have to do the pro things in order to look like a professional. But the professionals aren't working on a 31-year-old Elantra, and that's what I love about working on this car. You can see the EKG working overtime here, and I don't really care about much of any of this until the car enters closed loop operation at warm idle. For the first minute on a cold start, your car's in open loop mode and it doesn't care what the sensors say that your fuel should be doing. It relies on its defaults, and those are affected by other features like cold start enrichment, for instance. There's a table where additional injector dead time can be added to temperature points below normal operation. So until the engine temperature reaches up to or around 180, and all I'm really doing right now is just proving that these injectors all work, and they do. And of course, get the engine temperature up to where I need it first. Once closed loop operation begins, and once it's up to operating temperature, then I'll observe a few values and see whether I'm rich or lean with my starting point, and then figure out what has to change. Hey, we just entered closed loop. Now the only thing affecting fuel trims is cold start enrichment. We'll wait a few minutes for that to settle down as it warms up, and while that's going on, I might as well do some of the pro things that I should have done before I started it and check for fuel leaks. Nope, none of those. Can't smell it, can't see it. I can tell based off the logs this far that it is running rich. It's pulling less fuel than it was a minute ago, but it's still a good 10% rich because combined fuel trims say it is. I know I haven't dialed the injector voltage dead time values in yet, and I think I also left a bunch of dead time in the fuel tab for the old injector settings as well. Of course, an engine setup as loose as this one, I'm not worried about hurrying it up on the temperatures a little on the launch limiter when it's only been running for a couple of minutes, but it's a mousy front wheel drive launch limiter setting to begin with, and it's only supposed to make 1 or 2 psi. Not going to hurt anything on this one. Not warm enough yet, but also not the right injector dead time setting, so I'm going to go ahead and fix those. Can't set them with the engine running either. The injector voltage dead time settings are in direct access. The values that I have to use here are supplied by the manufacturer, but they don't all line up with the voltage points that ECM Link gives you for adjustment. I entered the values that I had, and I interpolated the ones that I didn't to accomplish the exact same thing, and of course after doing all that, it crashes while saving. Hey, I'm the idiot using a 13-inch MacBook from 2012 to do all this. Even though I know good and well what the definition of insanity is, I still tried doing it the exact same way again. Some people just don't ever learn, do they? But lesson now learned, or result now confirmed, however you want to look at it, we'll try changing just one of the values and then saving it. Maybe it likes that. Nope. Okay, let's turn it off and back on again for all the people who will suggest this option, and then let's start on the opposite end of the graph one at a time and see what that does. Hey, it liked it. Let's do the next one and save it. And the next one and save it. Alright, we're on a roll. Just 2 left, and it appears that I found all the ways that don't work as well as the one that does. I don't really care as long as it still does the thing. Once the engine was warm, I continued tuning for about another 20 minutes to get her dialed in before an old gremlin returned, and it was pointless for me to continue for this demonstration once it began. And I'll explain this. I believe I've been having ignition problems, and I've been chasing my tail for many years, rewired the entire car trying to chase down all the issues. And it fixed a litany of problems when I did that. The car's never ran better since I rewired it. But this is a part I've never changed. And after doing the fuel injector upgrade and getting to the end of the tuning where I had everything looking great on the long-term fuel trims, on the low settings and on short-term fuel trims as well, all of a sudden it went full rich, started stumbling, shut off on me, and for 5 to 6 hours, nothing happens. I can't get it to start again. It runs and stumbles, runs like crap. I can floor it and try to do things with the gas pedal to make it squirt the injectors while I'm trying to crank it. And it seems to help, but it ultimately fails. And so what I'll wind up having to do is let the car cool completely down, and it takes 5 to 6 hours before I can come back, turn the key, and fire it right back up again. And it runs fine. There's absolutely nothing wrong with it. If this sounds like a PTU problem to you, well, I guess we're going to find out. The problem I've been experiencing with this car seems thermal. Power transistors have been known to fail from heat, but I'll tell you right now that I'm barking up the wrong tree. I've seen plenty of anomalies in my airflow signal over the years, and when Matt and I dyno tested the performance subwoofers, we saw it then too. I replaced the Omni 4-bar map sensor with another unit, and that got us through our dyno session. The PTU seemed like a logical next thing to replace, because it's the only thing I haven't. And of course, just as soon as I replaced it, the car fired right back up again. I backed it out of the shop for air quality reasons and grabbed my laptop off the charger to see what it was doing. This seemingly confirmed my theory, because if the PTU fails and the fire goes out, the wideband will read rich from all the unburnt fuel. That's the only data I could work from, because all the other times it shut me down, I wasn't logging. About a half hour into this test, just like before, I caught it in the act with Matt as my witness, and we have a log to prove all of it. It's a thermal issue, but that's not all. This is really nerdy, but it's actually cool to see this because I didn't change anything about my tune since the last time it did this. All the long-term fuel trim values are a mess from it still, but I just hit warm idle and that's going to change. Look at the Omni 4-bar. It says that I'm pulling minus 13.6 inches of mercury for vacuum with the engine idling at 200 degrees. So I played around with the launch limiter to put some heat in the motor, and it did. I got it briefly up to 206, and now everything on the fuel trims is fine. Combined fuel trims are all like, we're good here, party on, bro. And then look what happens just a few moments later. Suddenly at 0% throttle, the vacuum drops. I lose about an inch of mercury right before a spike occurs, where suddenly the ECU is seeing 5.3 pounds of boost, calculating a 25.9 to 1 air-fuel ratio. I don't think I've ever been that lean before in my life. But where it recovered from that, and this is weird, now I'm down 3 inches of mercury from where I was when this log started. And it starts pulling fuel like crazy. And you can see that the combined fuel trim's in the minus 20s. This is because the map signal drifted me into a completely different row on my VE table. Again, I didn't change anything. The only thing that's changed is the vacuum. I could feel and smell the car running rich, and for giggles, I gave it the launch limiter, goading it to just go ahead and fail, and I got my wish. What's different this time on the rev limiter is that it's reading almost 2 more PSI on the launch limiter than it should have. Next, it does some open loop things, and once it goes back to closed loop, and I'm still missing that vacuum, it starts to drift again, steadily climbing, and the calculated AFREST value creeps right up with it. Lean, 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 and then BAM! 40.1 PSI of boost at idle, the maximum this sensor can read, and that's with the throttle plate closed. That makes plenty of sense, doesn't it? Completely normal. We all knew the Elantra was a mighty beast, so naturally at 40 psi and 0% throttle, you get negative 2 degrees of timing and it drowns it in fuel, dies on its feet. So at this point I've been through 2 different map sensors, rewired the whole engine, and I can only conclude that this is a thermal issue. We'll get Abe over here to check the electrical system just in case, but it happened after about 40 minutes of use, and it caused the same exact behaviors that I experienced when it broke down on me trying to drive it to the shootout last year. It's because the Omni started reading less and less vacuum than it actually had, which is the most significant variable in what data the ECU samples from on the VE table for fuel. Apparently I've done it to myself. Map sensor got hot, sent straight 5 volts to the ECU saying I was at 40 pounds of boost. Naturally, it put me at 2 degrees of timing advance, flooded the engine, and stalled the car out. I had this brilliant idea of mounting my map sensor to the ground bracket for the throttle body. Once this thing gets hot, once the cam angle sensor gets hot, and I've used a laser thermometer and checked everything in the engine bay to see what's the hottest, and it's 20 degrees hotter than everything else. Once that thing heats up, it just seems to short to a 5 volt, just opens the circuit. So I'm going to get another one of these. In the meantime, I think I'm going to move its location to this now open spot where we used to have a resistor pack. I think that's a smart thing for me to do. Relocating the sensor means relocating the wiring and putting a longer vacuum hose on it. It doesn't sound so bad, except that I'm now having to cut tape and completely gut and redo the custom Elantra 4G63 harness that I made and reroute the map sensor wiring through another already finished part of the harness to find its new home. All of this looked great before I started, and I intend to leave it better than I found it. But it took an uncomfortable hour, really more like 2 hours, just to move 3 wires, reassemble and retape everything. Next, I get to find a long enough bolt that fits the nut-cert, and that's easy. But because it's Sunday, I had to quit and use my next lunch break to go pick up a map sensor so we could move on with this. I quit the old one. No sense in plugging that thing back in if I cooked it. The one I'm getting is the same style 4-bar GM map sensor, but it's a different brand. Well, people, everybody's looking for the international supplier of 4-bar map sensors, Ballinger. Anybody who searched 4-bar GM map sensor has likely found Ballinger, but they're here. They're right there. Can't tell from outside. International headquarters. Yeah, people, don't do what I just did. Ballinger sells everything automotive electricians crave, probably even things with electrolytes. But do them all a big favor and just buy it online. I'm reusing my hose clamps because they're nice and crusty, just like everything else under here. I liked having a short vacuum line for a more responsive sensor, but it was just too hot where I had it, and I kept cooking them. Or so I think. In addition to that spot being right above the thermostat housing and the heater lines, you know, in my tests probing around, the cam angle sensor read 50 degrees hotter than the coolant system ever gets. I'm sure being sandwiched between that hot cam angle sensor spinning right next to it and a throttle position sensor on the other side, both of which generate magnetic fields, I'm sure that wasn't helping anything either. As hot as these parts get, I suppose it isn't so bad having a long hose after all. What? Yes, that is my PVC port that I'm using as a boost source. Looking around the rest of my engine bay, you can tell this didn't really need to be pretty, but all this effort at least kept it from looking and fitting really, really bad. And that little snap was really satisfying to me because now I'm done. I finally get to clean all my tools and scraps out of the engine bay, close the hood, and go fire her up. I can't wait to see if this fixed all of it. Oh, I left it on. Killed the battery. Let's see how she does after a 24-hour cycle on the defibrillator. There is no fuel. Excellent. What did I do wrong? I had to do this. It's got to be me. I told you it was my fault. In my process of rewrapping all of this, the fuel pump test connector, that one right there, that's supposed to be plugged into a wire over here somewhere that I ran to the relay. There it is. Now I'm about to have fuel. Click, turn the car on. The relay's working, but something's not making contact. So I was over there messing with this thing a lot. This thing. There we go. I don't like that at all. The relay ground pin seemed to fit the socket a little bit better than it did on the actual pin of the relay, so I gave the connector a little squish so that it would grab the pin tightly again. Alright, now we've got fuel again. It was my fault. Well, that settles it. You just watch me fix the air, the fuel, and the fire. Let's try this again and see if I can finally maintain a consistent airflow signal over a long period of time. As you can see, it's been idling for a long time. A little over an hour and 10 minutes now. I've got it idling at 750 RPMs, which is a little low, but it sounds great. Combined fuel trims are near zero, within 0.5%. Matt's on vacation right now. We can't get it fully tuned until he's back, and I think we're going to go ahead and get this thing on the dyno and see what the difference is between pump gas and e85. You can do the math on the logs. That's, you know, a lot of seconds, but this is the second log. Combined fuel trims are doing all right. I've got the cutout open right now. If I close that, that'll actually correct itself. There you go. Now it's closed. Doing good. I know y'all are already sick of looking at this log, so I'll go ahead and get out of this. We'll wait for Matt to come home. Fortunately for all of us and my Hyundai, Matt did actually come home, because now we have this. We spent a total of 5 hours on this car over 2 nights squashing bugs, and I have almost the entire thing compiled on video with data logs at normal speed. It's one of the biggest video files I've ever created, but you guys don't have anywhere near that long to spend with me on this. I don't know if my YouTube audience could even handle a 4-hour video, but I bet it thinks I probably would do that to them. I'm not going to go deeper into what's and whys here, except to explain that this evolving airflow table is the rescaling of my new very large fuel injectors that are capable of delivering enough gasoline or E85, however it's mixed, to run as cleanly and efficiently as possible. Even though you have to burn more ethanol to safely do the same thing that you could do with less gasoline, it still burns cleaner. This 90s economy car that still to this day meets emission standards with its catalytic converter can take advantage of using an even cleaner, more sustainable biofuel sold at gas stations around where I live. But essentially what's happening is we get it as efficient as possible for pump gas on the minimum tables first, and then do the same for the max tables on ethanol. By testing this engine under a variety of different loads on the dyno, we're able to quickly achieve that proper mixture for every operating condition. My car supports the operation of an ethanol sensor. And by having that, my sensor is giving me the ability to supply the correct volume of fuel based on its density, and adjust the timing to compensate for gasoline's volatility as well. But even better than that, it lets me use whatever ethanol content fuel that's available at my local gas pump without me having to grab a laptop and adjust my air-fuel ratios to get that right. The ethanol sensor helps my ECU do all of that for me. Ethanol support in the 90s was only for about 5 to 10% content tops, not the 80 to 100% ethanol varieties now available in different locations all around the country. When ethanol support was mandated, the manufacturers did what they knew how to do at the time. They changed a few materials and, made every car run 5 to 10% more rich. That actually creates more emissions, but the way manufacturers did it then, the ECU didn't actually check to see what the ethanol content was. It just assumed that 5 to 10% of it was there, and it listened to the NOx sensor to pull timing. It makes even more emissions. Just seems smarter to me to use more stable fuels that are widely available in the right mixture to eliminate both NOx and emissions. No brainer. Make it efficient. So first we got the gasoline air fuel mixture perfect, and verified our results on the data logs by reading spark plugs, ensuring that they were matching up with the data that we're looking at on the screen. Once satisfied with its stellar performance, it was then finally time to turn my Hyundai into an alcoholic. 5 gallons of E85 from Sheetz. This is on top of my probably less than 2 gallons of 93 octane. This is enough to get the mixture above 50% so that we can continue dialing in the max tables for ethanol. It turns out that the knock I've been fighting all these years is indeed actually real, but that's not the only problem I've been fighting all these years. See, oh, look at that. We still got spikes in it. Look at that shit. The EST value is all over the place when breaking up.
Yeah, but the fueling was steady.
Spot on.
I'd watch the and put this on over top of it.
Which one?
Injector on, yeah. Okay, so it is doing some weird shit right there.
Yeah.
Why?
Doing it here too.
That we know what's going on in the spool up. But why is it doing that is the question. I mean, what's the pulse width? Whoa. Yeah, that's not okay.
What pulse width?
That's your injector pulse width. And it's going from 10 to 7 milliseconds. That's huge.
Yeah.
Why is it doing that?
I don't know. Multiple people have helped me multiple times try to squash this, and all the research led to experimentation that did not previously solve my problem. And nothing we did after that helped us clean it up either, so the next morning Abe came out to help with some of his equipment to chase some of our other suspected possible causes for this type of thing. Long story short, AFR EST is a calculated value, and there's no noise in any of the values being calculated that we can see in our logs.
What's going on here, Abe? So what we're going to try to do is we want to scope the 5-volt reference and the map sensor return signal on there to see if we have basically any EMI, electromagnetic interference, that is caused either by electrical noise from the coils or possibly fuel injectors. But I want to see why you're having issues with the map sensor failure.
Yeah, and this is just for reference voltage?
Yes.
You're going to scope this and watch to see if anything weird happens in the main power?
Yeah, that'll tell me if you've got problems with diodes in the alternator, if you've got an AC ripple that's causing issues there.
Okay.
Then we'll go back and we'll actually scope the cam sensor, crank sensor outputs off the cast on there and see if that has any issues with dropout at high speed.
All right, word. Thanks, man. What about this scanner here?
So this is a Snap-on Varus. It's a little bit older unit. Right now I've got it set up to run as a 4-channel scope, so we can see some of the raw signals that are coming in and capture them at a faster rate than what the update rate on the ECU is. So little tiny ripples that you may see in the data log on that, it won't necessarily show some of the signals that we're going to pick up just because they don't have a fast enough update rate.
Okay. Cool.
This time I'm not going to rip it all the way out. I reckon I'll just rip it far enough to see if we get our airflow.
Okay.
Air.
So what we're looking for right here is to recreate that noisy airflow estimate spike thing that we were looking at earlier and try to catch anything that could be causing it in my electrical system using Abe's scanner. We've got essentially 3 different data logs going on simultaneously right now between my laptop, the dyno, and Abe's scope. And dang it if we didn't get it to do it again. We combed through all the data and variations on Abe's scope. Yeah, they were so fine that you could describe what we saw there as ideal. There's nothing triggering these events that's detectable, and that's frustrating because it's so persistent. It's just some invisible kind of data messing up all the math. Up to this point, I've now replaced all the hardware that could be responsible for this multiple times and with multiple brands. I rewired the car, I moved the map sensor, tried different plugs, coils, cam angle sensors, and transistors, yet still this persists. Robert and I made a little bit of progress with that noise years ago, utilizing the airflow smoothing function of ECM Link. But too much of it can be a bad thing because the best way I can quickly describe it is it makes all the math blurry. That could mean sluggish, but the big acceptable picture now is that what we need to avoid the most is wild rapid fluctuations in the math that's messing with the injector pulse width. The biggest victory this far is just having a stable map sensor signal because this car will now run all day long. The car shutting off never had anything to do with the power transistor, it was the map sensor. I now have the same vacuum at the beginning of a heat cycle that I do at the end hours later, and that's a huge improvement. So I conclude that it was a thermal issue cooking sensors.
I can feel it, I think, through the bowl.
Turn the speed on.
What happens if we turn the smoothing off?
See the speed line?
Yeah.
Yeah.
So I could see some little tiny pulsations in the output signal, but nothing like amplitude like that. I'm not seeing that. Just
I have a feeling it's small, the nuances that are causing massive
What-
adjustments.
Yeah, but it should never do that.
no.
That's
I mean,
an ECU.
your output signal is not fluctuating like
Yeah,
that.
I know. I didn't figure it was. And I would have thought turning the smoothing up would have helped.
Like your
Let's turn the smoothing off. How
Like
about
your-
that?
Would it make 383?
Yeah. Versus last time we made what, 389?
389 or something like that.
Yeah, but I took a little. What kind of timing? Oh, you already closed it.
Oh yeah, we could open it up.
I mean, obviously it's less. There's a full pull, so we'll save that one.
I'm going to interrupt here and summarize what we figured out over the next 3 hours. Airflow smoothing will eventually correct a jagged air-fuel ratio estimate in ECM link when you can't find the cause. It has the feature to do this. You just keep having to add smoothing percentages into the places wherever it spikes. No clue where all that noise came from, but we did fix it, and we made many more pulls beyond. In the performance subwoofer video, we took this car that made 273 horsepower and 230 foot-pounds of torque at wastegate pressure on 93 octane gasoline, and we made 364 horsepower and 343 pounds of torque as we turned the boost all the way up. We gained 91 horsepower and 113 pounds of torque with just boost. The cursor in this one is at peak horsepower right now, not peak torque, but it makes plenty of torque. You can see it's on a slump right there from its 93 octane peak. But now we're going to learn all about how much power it makes on E85 in the exact same circumstances and with big enough injectors for the job.
All right, man, let's give her the beans.
I wonder, is that a new setting?
What?
Use the latest speed for gear selection. Is that a checkbox that you had in your other one? 'Cause I don't think I've seen that one before.
I don't think so. No, we got everything saved. So live dialog, start capture, get in and close the door.
I had the wrong one. I had
Put it on hold.
What's weird is it doesn't smell afterward. Damn, I hit the panic button. Which, by the way, is the space bar. If you ever need emergency stop.
She stopped. Well, that sucks. I'll just turn it down 2 clicks. How about that?
I'm not happy on there.
Yeah, the clutch.
Huh?
The clutch.
Oh, you drove through it?
Yeah.
Yep.
Yeah, the most it'll make is about 370 torque until it drives through the clutch. What's weird is it never smells.
Okay, I've knocked it down a couple ticks.
Yeah.
This is also a higher load than what you would.
Yeah, it is. Because it's never going to see peak torque on the street unless you're in a low gear. So it really is never going to be in that situation. Yeah, what I'll do is I'll take a little bit of load off the roller to mimic like second gear or something.
Not gonna do third gear pull?
Yeah, we'll still do another fourth.
Okay.
But I took some load off so it can ramp a little faster.
Yeah.
Yep, the clutch went. The clutch in this car was the one that I put in the GSX before I blew it up. So it's a hand-me-down already anyway, but it appears as though we've used it all the way up because it's not holding anywhere near its 405 foot-pound rating. So the answer to how much power your car is going to make on E85 is more power than your clutch is going to hold. We were doing really good there for a minute. I really wanted to get you that number, sorry. The clutch pedal requires adjustment as it wears, and mine has also worn itself down to the point of preload. I fell short of the 400 that I was aiming for, but only because the clutch wasn't having any of it. 40 plus pulls turned up with it on its bleeding edge, and I think we cooked it. But we figured that we'd give her the adjustment and try it one last time just to make sure.
Now I was over there changing the smoothing on the graph, trying to see if we could, but it still only made 392.7, even with the smoothing.
There, we're logging.
All right. I mean, on the street, it's going to hold it anyway, either hold it or spin. But on the dyno, it's, 300, and it's getting worse because we made 372. At some point now we're at 366 is the most it'll hold as far as torque.
I've pulled boost out, but it's hot, huh?
I guess the clutch is warm, yeah. 366.7 is the torque it made right there.
Yeah.
And we've previously made like 370 before it slipped. So we've lost some torque capacity since we've been here.
How's the electrical system in the Hyundai?
I actually think it's pretty good shape.
Even though I just crushed all my old problems and excuses while completing this E85 upgrade, I really wanted this video to conclude both the performance subwoofer video as well as the E85 fuel system install videos with clear results. Now, almost got that number.
Instead, I got myself a clutch job. That's what I got. Oh well. This used 6-puck ACT Extreme should do the trick.
We won't know the amount of power it can make until the clutch can hold it. And what that means is I've got reason to do all the while you were in there mods that my Patreon supporters already know all about. That should shake things up a little bit around the Elantraverse. That'll be its own video though. We'll get Abe back here again for that one. I think this is a good time to break. I hope you enjoyed this episode. Thank you, Patreon. Please do the things with the stuff. All the stuff I tried to do with my thing fell short, and this is the best run we got out of it. This one right here is with the AFRs on the bottom, and you can see she's solid between a 1004 and a 1064 to 1 on ethanol. The double hump during spool up is my clutch slipping and not doing the thing I need right at peak torque. Perhaps this has always been an issue. Either way, today, this Elantra made 392.7 horsepower and 377 foot-pounds of torque on E85. I'll be back again soon with a new used clutch, and until next time, stay tuned!